Tell us everything.
Basically, I wanted to just talk about this mesocosm setup here. Paul designed it and built it, and it's been working for more than 30 years. I don't know if Steve told you about the temperature experiments when Hawaiian Electric was going to put a power plant, and nobody had thought about what was going to happen when temperatures were big. It's pretty close.
Right.
And somebody said, gee, maybe somebody ought to look at that. So there was these were set up back then, a long time ago, and temperature experiments were done with different degrees of temperature. And interestingly, there was, I think it's gone now, an exact similar system out at the marine base that was using open ocean water. I think that system's gone now. That was at Navy Ocean Research Center. And I think that's closed down now. But anyway, Paul designed this, built it, broke the lab, did the plumbing, did the carpentry, and as I said, it's been up and running for more than 30 years. People have done experiments with temperature, with light, different amount of shade, but with colored light. People more recently have been working on CO2, looking at ocean acidification. Kiko's working on sedimentation, vector sedimentation on coral. So you can do any combination of things that you want to do. And because we have 12 identical tanks, you can do replication to 6 warm water and 6 regular water. So the science that comes out of it is a lot better than just one shot. So, as I said, we've been doing stuff here for more than 30 years, and the system is still up and still working and still producing good data. So it's an amazing thing, and it's amazing partly because it's so simple. So on the way out, my 2 minutes are up. If you deal with saltwater, the pump house, our water goes up to the header tank. Water from the rest of the lab goes to the header tank on the other side. Comes down. When you pump seawater, you always get sediment, especially if it's a windy storm or anything. Stuff gets suspended. So keeping your system free of sediment is a big deal. Here, all you do is run through this thing, and the water will shoot out with all the sediment in it. And get it very wet and dirty, but that's cheap and easy. If you want to control the depth of the water, you simply screw this up, and the water gets deeper, screw down, and it gets shallower, so you can control the depth. Again, cheap and easy. Over here, so
Chan?
I never get questions like that.
He probably did. Good example of secondary losses, Huge amounts.
Thank you so much.
Thanks, Dr. Bob.
Thank you so much for engaging.
I started in 1980.
Oh, wow.
In fact, when I started out here, he was so knowledgeable, I thought he already had his PhD, but I found out he was just a PhD student like me. Yeah, I've been working with him.
Living in the laboratory.
And you know what you've been seeing so far is what we call the sexy science, the really cool experiments that he did, how sewage affects corals, how high temperatures affect corals, how ocean acidification can affect corals, all that really neat stuff that you need to know. But Paul also recognized you need to know what you thought and what's happening to it over time. This is not the sexy science. Nobody wants to pay for this. So it's very hard to get funding. So we worked very hard in the 80s and finally got funding from the Coral Reef Initiative to start what's called the CRAMP program, the Coral Reef Assessment and Monitoring Program. And if you see members of the family on the back of their t-shirts, they have the CRAMP logo. So he established on this map here, you can see all the red dots are sites that he established throughout the Hawaiian Islands. And the idea was to go there as regularly as they could and sample the corals. Corals are nice for sampling because they don't run away from you like fish do. They grow slowly, but they respond to environmental changes. And so if you want to know how such environmental change affects corals in this area, you need that baseline data and you need to be able to go back and check over how things are changing. So that's what is set up for Reef Monitoring System program. So it's not the sexy science, but it's very important. This tank is part of Mark Heckman's community education program. It's got some of the common things here on eBay. I put these in here today because we don't usually keep these corals in this tank because they get infected with a worm that kills them. So I just brought them in because they are our common corals of weight. This is the low coral, Porites lobata. This is Porites compressa. The finger coral, this is really, really common here today. And then Manticore, the race coral. It can take this branch form or it can take this plate form. Again, very common coral here in Hawaii. Very, very, like I say, they're the foundation species for coral reefs. So these are the main ones that they encounter when they go to all the different sites.
I'm gonna say, aren't those cowrie shells?
Yes, these are
I couldn't see it now that one's open.
Yeah, they have the mantle up over the shell, so you can't see the shell very well. But there's a couple in the corners. Yeah, and what we found out is this species likes to eat this orange sponge, and this is an introduced species here in Honolulu Bay. Yeah. So we're happy to find something that's chomping down.
Except that like all the humans like the cowrie shells, right? So.
Unfortunately, humans like them, well, and they have to kill the animal to be able to.
Right. Oh man.
So you see, this is the mantle that actually
same on the side of the road selling them.
Yeah. Yeah.
You're done now.
That's.
Huh. Cool.
And then this is a candy-striped sea cucumber. They're nature's vacuum cleaners. So you see here at the front end, you see all their tentacles. They just go along the bottom, picking up all the debris. You can see their 2 feet there. See how and we have lots of other types of sea cucumbers in here as well that are common.
That's what's the.
Oh, and I forgot to point out, the ones in the middle are mushroom corals. But these ones get fed all the time, so you don't need mushrooms. They're really very healthy. They have their polyps out all the time. They're really happy to be in here.
Yeah, I used to see these when I was out here before.
Oh, these are really common in
I
Bay.
thought it used to be like thick.
Last one.
40 years ago. Wow.
Yeah, it's funny. Did they ever like recruited us out here to help build stuff?
They were
I guess we were.
neighbors.
I guess we were like
The next door neighbor growing up.
we were kids in high school and stuff. And we knew him. And we knew he was a scientist. He worked at Coconut, but and came out and played, you know, a little bit, but never really kind of. Like thinking my son, I'd make him come to work and help me. And I don't even have anything nearly as cool as this, you know.
Well, his kids used to come out with him.
Yeah, that's who we know Jordan and stuff.
Yeah, they would just run around and play around. And I remember them. They were just Yeah.
gives me a different insight on Jordan because he doesn't know how to build anything.
Yeah.
I'm thinking, man, your dad built all this stuff. How come you don't know how to do it?
Rubbed off.
Yeah. It's a generation thing. For me too, my parents weren't really into it, but now I have to learn everything. So, and I like it. It would be great if I had the interest and knew. Oh, come on, let me volunteer. I'll help you build today. I would have learned a lot from him.
Yeah. He was a
I got to
well-rounded
cramp with
guy.
him. I got to dive with him on a cramp thing for Hawaii.
Oh, okay.
One time, one of the grad students couldn't make it, and I was a UH diver, and so they were going to come along. And so, yeah, okay. So yeah, it was really fun. It's interesting to see the the science up front side of it. Because I work in sea level, and but I'm a technician, so I go and fix the equipment that gets the data.
It takes all the Bible to make right. Not just the students.
Yeah.
Legions and legions of graduate students.
Yeah, people are still interested in doing it.
Yeah.
Great. Well, we're gonna head back. I think there's gonna be.
One more group?
I think Akiko's gonna turn her group around. There might be one more group that comes through.
Okay.
But thank you so much, Denny.
Oh, that's okay.
Thanks for meeting you.
Yeah.
Yeah, we'll just walk right back across the
First group of people walking around this island. I was a graduate student here, so Paul was one of my mentors. He taught me a bazillion things, and mostly he gave me access to how to learn how to be a scientist working here on Coconut Island. And let me tell you some of the cool things he was doing. So, about, excuse me. There we go. So there's Paul on the left, and two of his early colleagues. I'm going to talk about work that he did in the 1970s, 40 years ago. Steve Coles, who you saw just a minute ago, I think, on your tour, and Eric Dinther, who I'm sure is here somewhere today. So they did the first studies on coral bleaching, and this was prompted by what was going on at a Kahe power plant. Anybody know about the power plant out there? So they used ocean water to cool the turbines, and guess what comes out then? Warm water. So they were interested, those three people, in finding out, okay, what effect does warm water have on coral? So they did many, many, many experiments here, and then they repeated here on Coconut Island, and then they repeated these experiments at Mid-Pacific Marine Lab at Eniwetok.
Where's Eniwetok?
In the Marshall Islands, yeah.
Micronesia.
Micronesia.
Nice general.
So the water temperature here today is about 25 degrees, I'm guessing, 25, 26 degrees Celsius. And then we talk at this time of year, similar time of year, it would be close to 28, 29 degrees centigrade, so a lot warmer. It's really fun to work in places like that, which are truly tropical and nice warm water. Steve Coles was just telling me a story though. When they were doing the work here at Coconut Island, when they first started, they had to cut down the bushes to get out to the place where they were going to set up the point facility. They had to blaze the trail. And Finney, that we were just talking to, Dr. Cox was just reminding me, and to get out there, the bridge to the point was 2 8-inch wide planks that were kind of separated across the lagoon here by little pontoons. So you had to walk out there like this, and if you had your hand full of test tubes, it was fun. Well, we just didn't think anything differently, it was just the way things were, right? Some things don't ever change, some things stay the same. Or some things change, some things never do. So just quickly, I think Paul would be happy to, if you all knew that a healthy coral has little cells inside their cells that are algae. And what do algae do for a living? They take energy, they photosynthesize, they take energy from the sun and turn it into food. So we have food thanks to plants, and so do reef-building corals. These little algae make food for their coral hosts. So this is a neat symbiosis, but when corals get stressed, this relationship breaks down. So sad, relationship breaks down, it falls apart, and actually the zooxanthellae, these little algae, leave their coral hosts, and then the corals look white. So that's why it's called coral bleaching. It has nothing to do with Clorox. This is a separation of that relationship. When the golden brown algae have left. So when they're gone, what's the coral gonna do? No food, starving, hungry. So until the corals can get those algae back inside, they are very stressed and they're doomed to die unless it happens. So Paul and Steve Coles and other colleagues found this out in the early to mid 1970s, 40 years ago. This is before anybody ever talked about global coral bleaching. In Hawaii though, now we've had 3 major events, 1996, 2014, and 2015, where the water temperature here got warm. And these guys figured out that all it takes is for the water temperature to warm up to 1 to 2 degrees above average summer maximum, just 1 to 2 degrees warmer in Hawaii, right? So wherever you are. So in Hawaii, summertime maximum is about 27 degrees, so all it's going to take is going up to 28 or 29 degrees. And in Inuitak, it would take going up to, say, 31 or 32 degrees for it to make that relationship fall apart. So this shows some of the historic bleaching patterns. I've been told that I have to get out of here, get you on the road again, so I'll speed up it.
We wish we could stay longer.
I wish you could. You can come back anytime and we'll be happy to talk more about coral bleaching. This shows what we have now. These are global satellite imagery showing water temperature around the world at any particular week in time. Here is 26 to 28 degrees. This was 2 years ago now, 14. But NOAA helps us visualize what the water temperatures are so we can anticipate. We're going to see coral bleaching, temperature 1 to 2 degrees centigrade above the summer maximum. And that's what it looks like underwater in Kaneohe Bay. Paul and colleagues published dozens of these are seminal, this is just from 1974 to 1978. Now, since his time, which at that time people thought, what are they doing? You know, okay, it's about a power plant. But actually, now we know that these papers have great import, and there have been hundreds and hundreds of papers published on coral bleaching, and they all point back to the work that Paul and his colleagues did here, Coconut Island and Inuitak. Also, we know the world is getting warmer. Paul's message when he talked about coral bleaching for us all was, eat lower on the food chain. Eat lower on the food chain. Eat lower on the food chain. God said it, Paul. Okay.
Thank you so much.
Thank you for your time.